Now, this next part of the lesson, you've been given these equations before. Such as final velocity equals initial velocity plus 2 acceleration over a change of distance. Now we're going to deal with the vertical. So, Vy final equals initial velocity times sine squared plus 2g for gravity times y. And then, of course, final velocity equals initial velocity plus acceleration and time. Now we're going to be adding angles and projectiles to this equation as well. So it becomes final vertical velocity equals initial velocity sine plus gravity and time. Now both of these equations are vectors, which means gravity will be a negative 9.8. Now the other day we talked about how projectiles are launched at an angle. In the beginning we were talking about the range. In this case, Ry. Also, range for Rx. Yesterday we spoke about positions. Today we're going to be dealing with time. Now as a projectile moves through a trajectory, it can be broken down into its vectors. As in the previous unit, you have sine vectors and cosine vectors. And then of course you have the full magnitude. Now it was also taught that gravity has a direct effect on the vertical velocity. And it is most noticeable here in these equations. So now let's have a few practice problems. Football being thrown at 20 degrees with initial velocity of 40 meters per second. Determine vertical velocity when it reaches 7 meters in altitude. Now let's identify all of our information. Initial velocity, 40 ms. Degrees, 20. You're solving for Vy final, at least in comparison when y is 7 meters. Now bring out the equation. Vy1 squared equals initial velocity sine squared plus 2g times y. Now we are solving for Vy1. Initial velocity is given as 40. The sine of 20 squared plus 2 times negative 9.8 times 7. Now let's find the sine of 20 first. Multiplied by 40. And then of course square. 187, 164 plus 2 times 9.8 negative times 7. Negative 137.2. Add these two together. $49.964. Now we have a square, so we perform square root. Vy final is 7.069 meters per second vertical.